two files each. So 150 to 160 files I'll be downloading. So that time I'm not going to search that, okay, this group has not submitted. I'll just look into the group details who are submitted, how they have answered, and I'll mark them. And you will not get a time because April 18th your exam. So I'm repeating this, and that time you come back and say that I have submitted, you have not marked, you have not evaluated. I'm not going to listen to that. So that's I'm continuously telling, name your files correctly. One Word document or PDF document, that is up to you. So where you'll write your research objective, analysis, data, descriptive analysis, everything has to be written down, explained, right? What insights you're getting from the data, whether your hypothesis got rejected or could not be rejected. So there are 4 research objectives. For each of them, you have to write alternate hypothesis, null hypothesis, then accordingly carry out the data analysis and write down your results, right? So that has to be written in a Word document, and you can convert that to PDF if you want, right? So that file has to be named, let's say section C underscore whatever the group number, group 5, group 6, group 8 or group 1 dot document or dot PDF. Same thing for the Excel file where you are carrying out the analysis. So Excel file also has to be named properly. Both the documents has to be uploaded, and in the document itself, write down your names and roll numbers correctly. Sometimes you put 00, or let's say roll number is 74 and you have written 274, right? So those kind of mistakes, do not do it. Make sure that whoever is uploading from your group, make that person responsible for checking the roll numbers and names in the document and accordingly upload that. Because I'll be checking around April 14th or 15th, and I'll just upload your, obviously I'll show you that what are your final marks out of 20, 5 assignment and 15 is project. But you will not get more time that, okay, I have not submitted, I need some extra time. Regarding project, any doubt or regarding assignment?
Sir, what is the deadline for the individual assignment?
9th of April, and your project is 13th of April.
Okay, sir.
I think I mentioned that in the Google Classroom. So that is there in the deadline. The due date, if you see it is there. Yeah. So because in the assignment, again, whom you are sending to the respondent, because it is not that you have to submit anything, right? You are not going to submit any file to me. Just ask them to, there will be a question, right? Please mention the email of the person who has sent you this survey. Ask them to put your email ID or institute email ID, not personal email ID, your institute email ID or just your roll number also, right? Because your email ID is nothing but your extension of your roll number, right? So that part, make sure that, because I'll not know who was filled for whom, right? So that is something, be extra careful whom you are sending, make sure that follow that they have submitted using your roll number ID. When I say using, so in that row, in that question, they are filling your roll number, right? Email ID of the person who has sent you that survey. So your roll number or your email ID has to come. So I can know that, okay, for this person I have got this many responses. And for your project, all the roll numbers, all the names has to be mentioned correctly, because whatever names, if you have missed somebody's names, I'm not going to ask you again, right? Because most of your, I think section C and A, I have received the group details. Other sections still I have not got the group details, so I will not know that who actually is there in that group or not, right? So any questions on your project? And first question, which is your data, descriptive data analysis. When I say descriptive, just look into the data, right? There are 1525 rows, right? What data tells you, right? Create some bar chart, create some data visualization, right? So that anytime you have a data set, that is the first step you have to do, whether that is given or not. Anyhow, I have written here. So just look into the data, what that data talks about, right? Create some pivot table, create some chart, bar diagrams, pie chart. Look into what kind of information insight you are getting from the data set given. So that is your first section. In the second section, there are 4 research objectives, right? For each of them, you have to write the hypothesis and whatever data analysis method we have covered so far, right? So all those hypotheses can be tested, whatever we have covered so far, right? So there is nothing new that we have not covered. Okay, so that's all. Any questions? Any doubt on this?
Sir,
Okay,
if we
yeah.
send, sir, if we send the form and he will not put our mail or name, then how will we know that, sir, he filled or not, sir, and given our name or not, sir? That is a very,
So ask them like when they're submitting, there will be thank you for submitting your survey, right? Just follow up them, they have filled it up. So if you are getting 10 responses, each of them at the end of the survey, they'll get that thank you for responding. So that if they can share with you that yes, they have filled it up.
sir,
Okay, so please pay attention to your roll call. Avinash,
Present, sir.
Avinash Patnaik,
Present, sir.
Aditi,
Present, sir.
Aditya, Aishwarya,
Present, sir.
Aliva,
Present, sir.
Alok,
Present, sir.
Anuradha, Haritra,
Present, sir.
Arpan,
Present, sir.
Arpan Narayan,
Present, sir.
Ashish,
Present, sir.
Abhik,
Yes, sir.
Bhaskar,
yes, sir, yes, sir.
Chandita,
Present, sir.
Chinmay, Debopam,
Present, sir.
Dipsika,
Present, sir.
Gautami, Itisri,
Present, sir.
Maheshweta,
Present, sir.
Nirvik,
Yes, sir.
Pratyasha,
Present, sir.
Pratyush,
Yes, sir.
Rahul,
Present, sir.
Rajeshwari,
Present, sir.
Rishabh,
Present, sir.
Minakshi,
Present, sir.
Sadeep,
Present, sir.
Sambit,
Present, sir.
Sambita, Santanu,
Yes, sir.
Samran,
Present, sir.
Sarda,
Present, sir.
Shivam,
Present, sir.
Shreya,
Present, sir.
Shreya Shruti,
Sir.
Sneha,
Present, sir.
Soham, Soumyajit,
Yes, sir.
Subhajit,
Present, sir.
Subham, Sunit,
Present, sir.
Tini,
Present, sir.
Yes,
Present, sir.
Aditya, Avinav, Kumar Aditya, Shivani,
Present, sir.
Piyush,
Present, sir.
Itisri,
Present, sir.
Divyajyoti,
Present, sir.
Siddhant,
Present, sir.
Shashwat,
Present, sir.
Sonali, Naman, anyone who missed attendance?
So 174, am I marked present because I
Yes.
think I was not out. Okay, thank you.
Gautami roll number? Gautami Srivastava. What's your roll number? Okay, 17.
Sir, 170.
Okay, she has put in the chat message. Okay, so before we start regression, can anybody tell me what is the difference between correlation and covariance? Sir, okay, we'll come back to correlation or covariance later on. I think QT and this is an interesting technique, right? Those of you who are interested in analytics, right? If you are able to cover all the basics of regression, right? 50%, 50 to 60% of your analytics problem can be framed into a regression problem, right? Most of your interview questions will be based on regression because that is the most used or abused, you can tell it in other way, a data analytics method in any kind of data science or any kind of data analytics project. So this and this regression will get repeated across different subjects. You have been like kind of covered in QT1, in BRM we are going to cover, in marketing research we are going to cover this, then in your any kind of analytics, whether machine learning, predictive analytics you take, R you take, analytics toolbox you take, repeatedly you look into regression, right? And you will get into different viewpoints of regression, right? So it is not that we are repeating it because same thing we are going to say. You'll say into in different classes there will be certain additional information or additional insight you'll get into regression, right? So when we talk about BRM, right, in QT already you have covered regression. How it is different or how we are going to look into regression will be little bit different, right? So first let us discuss, right, why regression we are utilizing in the QT. Like, can anybody tell me how you have used regression? I think some of you have covered QT project in regression also, right? Covering regression or using regression. How you have used regression? Can anybody give me an example? Any one of you?
So to find the relationship between dependent and independent variable.
Okay, to find the relations. Yeah. Yes, Ashish.
Yes, to find the relationship, the factors are actually affecting the dependent variable or not. That's you are finding through regression.
Okay.
The independent variable or independent variable. That independent variable is in relation to the dependent variable or not.
Okay. Then how do you interpret that? If I say that if I show you a table, okay, let us do that. Just give me a moment. So, okay, so we are going to do this exercise today, but let us go a little bit like other way around. So I have this kind of table like, and I want to understand whether, so my dependent variable is basically salary, right? And my independent variables is gender. One is independent variable gender and work experience is number of years, right? And this is how we are doing this. I think almost all of you know this, how to use Excel, but anyhow, I'll show this later on. But let's say I have got this summary output, right? So how do you interpret this? So when you say that I have to find a relationship between my dependent variable and independent variable, right? So I hope all of you know that these two are my independent variable, right? And my dependent variable is, let's say, salary, right? Which is given here. So gender, work experience, and salary, right? So how do I know that there is a relationship or not?
So we will see the p-value. That will
The
P-value.
thing is
Individual p-value.
significant or not.
individual and overall p-value.
0.05 is less than the p-value, then you can say that's significant.
They are significant.
Okay. So if I say this is significant, what does it actually mean? So if I say that, okay, these all the three values are very small, right? So intercept I am not interested in, right? I am interested in these two independent variables. So when I say that these two are like independent variables and they are significant, that means that they have some effect on your salary, right? So what does it actually mean when I say that is the effect? So what is the significance when I say less than 0.05? In a hypothesis testing or in the research methodology framework, what do we additionally mean by this?
So we can say we cannot reject the null hypothesis.
Then what is my null hypothesis?
That there is no relation between the salary and the gender and work experience.
Work experience. And so in this case, if I'm getting a p-value is less than 0.05, which is my alpha, what will be my result or what will be my conclusion?
So then we have to accept the null, I guess.
Accept the null.
Yes, yes.
Accept or reject? So what did you tell your null hypothesis? Null hypothesis is there is no relationship between gender, work experience with your salary, right? So gender do not impact your salary, nor your work experience impacts your salary, right? So that is your null hypothesis. So if my p-value is coming like this, what will happen? My null hypothesis will be rejected or accepted?
Yes, reject.
So reject the null, I guess.
So this is where you'll reject the null hypothesis. So you'll say that no, my null hypothesis which says that there is no relationship, that is wrong. There is a relationship of gender with salary. There is a relationship work experience with salary, right? Now the second part is that what does it mean when I say relationship? What I'm proving here, because this is a sample, right? This I have taken for 30 professionals for whom I have taken their work experience, their gender, and I'm looking into their monthly salary, I guess, right? So in that case, what I'm telling in this sample, like, because see, hypothesis testing is always about we're taking a sample and making a conclusion about our population, right? So what I say, if I overall take, if I have taken my sample in a random sampling manner or stratified random sampling manner, so there is some probability associated with it, then I can make a claim that overall for the population, right, your salary is dependent on your gender, salary is dependent on your work experience, right? So hypothesis testing, we are making a claim about the population, right? So that is where research methodology. And second aspect of your regression, if I talk about analytics way, right? In analytics, or making prediction, we are much more interested in making a prediction or making a classification, right? It doesn't mean that we are not interested between the relationship between variables, but our main objective is to create an equation. Just think about a bank, right? So for a bank, or let's say for some of you who are getting interested in human resources, today's world, one of the key subject is human resource analytics, and two of the major problem what they solve using regression is prediction of attrition rate, right? Think about a company like Infosys, TCS, and all those things, right? For them, if they are able to predict for which, there are different projects going on, there are different new developments going on. So for those team members, if they can predict the attrition rate for region wise, for project wise, for location wise, if they are able to predict attrition rate, accordingly they can take their hiring decision, right? So attrition rate prediction is a big challenge in human resource analytics, which they use regression. Second is your let's say your number of people they need to hire in next few years, right? That is again a forecasting problem. Not necessarily a regression, but a regression is used. That is so much of a forecasting problem. So if you see human resource analytics, these are the two major problems where they use regression partially or regression fully to solve those problems, right? So in that case, what they are interested, they will have different information about their employees, their employee, how many years that person has worked, their gender, what is the education background, what is the location, whether their how what kind of performance ratings they have got, how many times they have got salary increase, like that. There will be lot of variables, right? But their main objective is not into the look into the variables, which variable is important, which variable is not important. Their main objective is to predict something. So if they are able to create a model, if they are able to create an equation, right, and say that okay, these having these variables, if this person with education background, these are this person's education background, gender, work experience, performance rating, what is the probability or what is the percentage of this person leaving the company, right? So this is something they are going to predict, right? So that is where regression will be helpful. So they are not much interested in the variables, they are interested in the outcome. So that is why regression is utilized in two ways: creating a prediction in terms of like whatever different field. If let's say I'm using this for a finance, what will be the stock price movement, right? If I can predict let's say IPO is happening, and if I can predict the stock price when it listed in a stock exchange, what will be that price, exact price where it will get listed? If can I predict this, right? So I'm much more interested in that prediction. I'm not that interested in which is independent, how many variables are there, right? I'm creating a model equation to predict something, right? So that is one way to look into regression, where I am much more interested in the outcome, what I'm going to predict, what is my dependent variable, and what result I'm getting, what is my accuracy level. Second part is, am I in this kind of research methodology, right? Which are the variables which is important to my model, right? Let's say in this case, if I want to create a model, gender or work experience, right, comes as a significant variables which is impacting a salary of a person, right? So they come, or they realize to be most important two variables, right? So in a research framework or in research methodology, we are much more interested in the importance of the variable, whether those variables are significant or not. In a prediction, in most of the analytic subjects, when you carry out the same problem, our approach will be to find out the much more accurate value for our dependent variable, right? And both are little bit different, though it looks like same. If I am much more significant, so this is where your R square comes into picture, right? So in this particular case, if you see, so I hope all of you know that R square. What does R square signify? R square signifies how much of your total variation is explained by your model, right? Can anybody tell me what is the difference between this multiple R or R square and adjusted R square? Why you have these two? So R square, not the multiple R, this one R square, sorry. Why you have multiple R is nothing but your correlation. R square is your coefficient of determination. What is this R square? What is the difference between R square and adjusted R square? Why we have these two numbers and those two are different? So why we have two R squares? One is R square, another is adjusted R square. Anyone? Okay. So R square, anyhow, I'll explain to that slide. R square means how much variation, total variation is explained by your model, right? So generally what happens when we keep increasing number of variables, right? If I just keep adding any new variables, right? R square artificially keeps increasing. R square, the value is something like 1 minus sum of square error divided by sum of square total. So that value keeps increasing. It doesn't matter whether that variable is significant or not, R square artificially will keep increasing, right? To avoid that, to unnecessarily increasing the number of independent variables, adjusted R square comes into picture. So adjusted R square penalizes. So I'll show you the formula of adjusted R square. Adjusted R square penalizes your model if you are including more number of variables. So what happens now, we'll be little bit careful. If you are adding one variable, it should happen that there is certain kind of logic behind it, right? Otherwise, what will happen? Let's say a person's location might not have anything to do with the attrition rate, but because it is by adding that location, R square value is increasing. I am getting a good model. I'll keep including that location, the number of traffic in that location, like that. Unnecessary variables, if I keep including, my R square value artificially, which is not true, right? Artificially will keep increasing. To avoid that kind of situation, we always, whenever you have a multiple linear regression means you have multiple independent variables, right? So single linear regression or bivariate linear regression means you have single independent variable. Whenever we are talking about multiple linear regression, we have multiple independent variable, right? So that is where we use adjusted R square, right? Generally, if you see, if you compare R square, adjusted R square value will be little lower, right? So why it is lower? Because as and when you keep increasing number of independent variables, it will come down a little bit, right? To make sure that you are not adding unnecessary independent variables, right? We will come back to this table a little bit later on. But is this clear that what is the difference between R square and adjusted R square?
Sir, please again explain what is the
Okay,
difference.
so R square, I think all of you know that what does R square mean, right? R square means if I creating a model, let's say I am creating a model like this, right? What does it mean? I'm creating a model where I'm claiming that gender and work experience, right, is impacting your salary of a person, right? So I'm creating a model where the final equation will be. So in this case, what will be my equation? Intercept, so that is the constant value 16,111 minus 17,200 multiplied by the gender plus 2749.2, right, multiplied by work experience, right? So that is my equation, that is my prediction model. What this R square suggests that 86% of this variation in salary, right, can be explained by my two variables or by model which contains two variables, that is work experience and gender, right? Now the problem generally what happens if I do not calculate something like adjusted R square, right? And if I, let's say I add another variable which is called number of family members, right? Number of family members of that person, or let's say location might be actually connected, or let's say something which is not actually related to a salary, right? Like that, let's say like number of family members, like that I keep adding certain variables, right? The formula of adjusted R square is in such a way that whenever you add a additional independent variable, R square value is going to increase. Most of the times it will increase. It is not that always it will increase. Most of the times R square value will increase. So in that case, what will happen? Some researcher, just to show that okay, their research they are doing carrying out a good research, right? So they can artificially manipulate that number. They can keep adding. So there is a site I think I was discussing. I was not able to find right now. So I think I was discussing in the previous class, right? So there is a relationship between ice cream sales and suicide rate in California, right? And they have been doing this research for last 10-15 years, right? Ice cream rates increase in summer, suicide rates also increase. So if I create those kind of models saying that yes, your death rates or suicide rates is dependent on your ice cream sales, that model doesn't make sense, right? That is, there is no logic behind it because R square will come around 90% is there, 0.90 or 0.92. So to avoid those kind of situations, whenever we are creating a model where a researcher might create a model unnecessarily adding these independent variables, like let's say gender, work experience, I add another variable called number of family members, right? Then what will happen? R square value will automatically increase by a certain point, right? And the researcher will tell that see, I have created a better model than you. I have created a better prediction model than you, right? So to avoid those kind of situation, adjusted R square is just a derivative of R square formula, which penalizes. I'll show you the formula, which penalizes in case you are adding any additional independent variable. Like in this case, I have only two independent variable. I have got a R square value. If I add another independent variable, let's say number of family members of that person, R square value most of the times will automatically increase to a certain extent. But whenever I'm adding a third variable or fourth variable or fifth variable into my model, adjusted R square will be negatively impacted. So to make a check that whichever variable you are adding actually has a logic towards it, you should not unnecessarily keep adding independent variables, right? So adjusted R square is just a check so that nobody, none of us, none of the researchers keep adding unnecessary independent variables, right? So that is where adjusted R square is different than R square.
Yes, sir. Got it.
Okay. So today we are going to discuss on, so I'll not spend much time on correlation or covariance and show you the formula, but I just want to remember one thing. So covariance is basically how two variables are varying together. Covariance, right? How two variables are varying together. So if I have two variables x and y, right? So formula of covariance x y will be xi minus x bar multiplied by yi minus y bar, summation of that divided by number of values or number of sample size, right? For the sample, as you know that we just reduce it by a little bit, sample size n minus 1, right? Correlation is a special case of covariance. So standardized value of covariance is nothing but a correlation, right? So if you look into the correlation formula is nothing but covariance between x and y divided by standard deviation of x and standard deviation of y. If x and y are metric variables, we use something called product moment correlation or Pearson's correlation coefficient, r varies between -1 to +1, right? So the correlation between two variables can be anything between -1 to +1. It can be 0. So what do you mean by when, let's say, two variables correlation is 0? What does it say? So if let's say my correlation between x and y is 0, what does it mean?
Means there is no relation.
No correlation.
Correlation.
There is no correlation. But remember, whenever we are trying to find out correlation, we are trying to find out the linear relationship, right? So if correlation is, let's say, 0, correlation coefficient is 0 or r is 0, that doesn't mean that there is no relationship. What does it mean? That there is no linear relationship. It might be a polynomial relationship or logarithmic relationship. We do not know that. We have to check that. If I find out r is, let's say, very small, 0.001 or 0.01, I should not say that there is no relationship. R0 means there is no linear relationship, right? Correlation basically trying to find out, because we use correlation formula to create our regression equation. Correlation is basically to find out whether there is a linear relationship between these two. When if I say +1, right? So there is a perfect linear relationship. -1 means perfect negative linear relationship, right? 0 means there is no linear relationship, right? If I can transform those variables, there might be a different kind of relationship, right? So what do I mean by that? Why that linear equation I'm not able to form if r is equal to 0, right? But I might form a linear equation y is equal to ax cubed or ax square or a log x, right? So that kind of formulation or that kind of equation might be formed, right? Even if r is equal to 0. R equal to 0 means there is no linear relationship between two variables, right? So other way around, one point to note that if there is no relationship, if actually there is no relationship, r will become 0. But r equal to 0 means that doesn't mean that there is no relationship. R equal to 0 means there is no linear relationship, right? Because correlation is basically to find out whether there is a linear relationship between two variables or not. So this anyhow you like I think.
So then what other relation will be there if there is no?
So that you have to check. So that is for where you have to do a scatter plot, right? So like this, you have to create a scatter plot, then you have to fit a equation into it. Whether it will be a logarithmic relationship or exponential relationship or polynomial relationship. So if you ask me like looking into a scatter plot, can you see? Yes, by experience. So you have to do a trial and error. If r is becoming 0, that doesn't mean that there is no relationship. You have to convert or you have to transform the variables and check that whether there is some equation coming. Y might be logarithm of x, some constant multiplied by logarithm of x. A log y might be ax, right? So that is something again you have to do a trial and error. Some softwares are there, when you feed those numbers, they will suggest some kind of equation, right? Even in Excel, you can do a line fitting, right? It will suggest a equation for you, but that might not be perfectly true. But it will get an idea that okay, the relationship might be like something like this, right? So, so Excel, there is something called line fitting you can do. In softwares like SPSS or R or Python, there are modules which will show you that okay, these are the probable relationship, right? Probable relationship, not exactly the one relationship. There might be different relationship between those two variables. What might be there? There might not be no linear relationship, right?
Yes, sir.
Well, so how to calculate covariance or correlation? Let's say this is my attitude towards a city. This example I have taken from a book, your marketing research. So there are 11 respondents. They have rated that how do they like that city from a scale of 1 to 11. Importance attached to weather, 1 to 11 scale, not important, 11 very important, right? Duration of residence, how many years they have lived in that city, right? So the formula of covariance is summation. So for that we have to find out the first average of those two values, right? So what we are trying to claim here is attitude towards a city. So that is my dependent variable, each dependent on duration of residence and importance attached to weather, right? So I have taken the y average, I have taken the x average. So let's say I'm trying to create my only a simple linear regression. So I'm saying that attitude towards a city is dependent on duration of residence, right? So that is a bivariate regression where I have two variables, right? Y average is equal to, sorry, y average I find out, then x average I find out. Then this is the formula of yi minus y average. So I find out for each of the respondent. Xi minus x average I find out for all the respondent. Then take a, so covariance formula is like xi bar minus x bar multiplied by yi bar minus y bar divided by, if I am calculating it for sample, n minus 1. If I am calculating for population, it is divided by n, right? So I have multiplied xi minus x average multiplied by yi minus y average for each of the column, each of the rows. I have done that calculation, then summed it up. That summation came out to 179.67. So when I want to calculate my covariance is the summation of that, what is numerator, divided by 11. Why 11? My sample size is 12. 12 minus 1 is 11. So this is my covariance. If I find my standard deviation of y and standard deviation of x, so if I divide covariance with standard deviation of y and standard deviation of x, I'll get a correlation, right? So this is again like you may not have to remember this formula, just to show that how correlation is related to covariance, right? So again here 0.93 means there is a linear relationship between attitude towards city and duration of residence by 0.93, right? Then your equation will be, regression equation is nothing but your coefficient. If I write a linear regression equation, y is equal to a plus b multiplied by x. B, which is the component coefficient of x, is correlation coefficient, which I calculated in the earlier case. Standard deviation of y, standard deviation of dependent variable divided by standard deviation of independent variable. So that will give me 0.589. So that I can put down into my equation. So then yes, I have to find out the constant, right? So I know that this is 0.589. So 0.589 into x bar plus a is equal to y bar. From that I'll calculate the constant value. So at the end, this anyhow I will do it in Excel. So at the end I'm trying to find out attitude towards city, how it is related to duration of residence. So how do I interpret this? Only thing in the calculation, you will not find your p value, t value, those things will not come, right? So for each year of residence, for each year of a person staying in that city or in that location, his attitudes towards the city is improving by 0.589 or 0.6 value, right? In a scale of 1 to 11, right? So then I can do it in a equation like kind of in Excel also. That is, and I will show you to that. But now the challenge is, if let's say somebody who has stayed here in this city is between let's say here, what is the value of this, 18, yeah, maximum is 18. Let's say somebody who has stayed in this city 25 years, right? So what will happen? Let's say if I want to predict the attitudes towards city, what will be the attitudes towards city?
Positive.
No, that is anyhow there. So I'm trying to predict, right? My equation is y is equal to 1, let's say 1 plus 0.6 into x, right? So that is my approximate equation. Let us forget this 0.78. So automatically what happens? Y is equal to 1 plus, let's say 0.589 is 0.6. 1 plus 0.6x. So what does it mean? For each year of that person's residence, that person staying in that city, that attitude toward the city is improving by 0.6, right or wrong? So if let's say that person has stayed 25 years in that city, so what will be the attitude toward the city?
Will increase.
No, you calculate what will be the value. So let's say my equation is 1 plus 0.6 multiplied by x is number of years that person has stayed, right? Duration of residence.
It is 16.
25 multiplied by 6, so how much it is becoming? 115 plus 116 here. 16, right? But look into what is our attitude rating. 1 is do not like city, 11 is very much like the city. So we do not have a value greater than 11. But we are getting a value of 16. So what does it mean?
So we have to adjust the R square value.
No, here there is no R square value, right? Here only I have only one equation. I have only one dependent variable, one independent variable. My dependent variable is attitude per city. My independent variable is duration in the city, right? And with these values, with this sample, I have calculated my formula or my equation is something like this, right? Now the problem happens till 18 if I put 18 into 0.6 around whatever it comes, right? Plus 1. This is going to give me a good prediction, right? As and when I crosses that 18 from 19, 20, 21, 22, 25. So this value, y value is crossing the range, right? Because I have a range from 1 to 11. This value automatically will keep increasing because if I put let's say 30 and this is 0.6, 30 multiplied by 0.6 is 18 plus 1 is 19, y will become 19. But my rating scale is from 1 to 11 only. Then somebody can argue that okay, if it is 19 means it will be 11 because 19 is greater than 11, I have a maximum of 11. Then what about which is a continuous variable, let's say salary or the number of years a person will live or the number of years a person will work in this company, right? So those are continuous values. That case those mistakes will happen, right? So regression, always remember the limitation of regression. The regression equation which you are framing, right, is true only within the range of values of dependent variables. So this equation will be only true in the range of values from 2 to maximum value of 18. Any value between 2 to 18 I take and I can predict correctly with because my R square value is coming good, I can predict correctly. But any value below 2 or above 18, I'll still able to predict, but that will not be a good prediction, right? So this is something you have to be careful about regression equation. A regression equation is valid only within the range of dependent variable. Is this part clear what I'm trying to tell? Anybody having any doubt on this? The equation which you have framed in a QT or any project, so that is not an absolute equation. That is not a universal equation. That equation you have framed taking a sample, right? So that equation will be true if you have got a good R square and you have got significant variables. That equation will be true as long within the range of your prediction. What is the range of prediction? The values you have taken for your dependent variables. Right? In my case, duration of residence is within the range of 2 to 18. So within that range, whatever I predict, I can use this equation. But beyond that range, I will not be able to use the same equation, right? Because in the sample, I have not taken that data.
But if we want to predict beyond that range, then how we will use?
No, you cannot do that. You have to create a range. So that is something known as extrapolation, right? So you will create a range for it. So it can be anything between this to this. In this particular case, because you have taken a survey scale, you will not able to do that. You will say that okay, in my data, in my sample data, the range of dependent variable was from 2 to 18. So I can predict only within the duration of residence from 2 to 18. And that is where like this e-commerce companies face an issue, right? Whenever they predict like, okay, let's say this person's market basket or the amount of money they'll spend on any kind of item, right? Because person's purchase behavior keeps changing every day, right? So that is not constant. But when I'm putting a equation prediction, I am taking certain sample data and making a prediction that this prediction will only be true within this range. To answer your question, in this particular case, if somebody says, if what about 20 or 25, somebody stayed 22 years or 23 years, my ideal answer will be I will not be able to predict using this equation because I had not taken those kind of data in my sample. Right? If you do not have the sample data within that range and I have created equation, I should not use that for my prediction beyond that range. Is this clear?
Yes, sir.
So let us quickly, I think all of you know how to create regression equations. So, sorry. Let me just share a file with you. So I'll quickly do this one. Okay, I have sent a file in this chat box. Please open this. So these are nothing but your examples for correlation and regression. Okay. So R square is explain variability in Y, right? Explain variability in your dependent variable, total variability in Y, right? Is the Excel file visible to all of you?
Yes, sir.
Yes, sir.
Okay. So, like I was discussing about adjusted R square, the formula of R square is nothing but 1 minus. So, this n minus 1 divided by n minus p minus 1 is not there in this R square formula. R square is nothing but 1 minus sum of square error divided by sum of square total. Right. Other way of telling is that sum of square of your regression equation, the explainability of your model divided by total variability of Y. So, total variability in Y is nothing but SS total, right? From total variability, if I minus or subtract sum of error, that will give me the explained variability of Y, right? So if you look into this adjusted R square formula, so this additional multiplication factor has come, n minus 1 divided by n minus p minus 1, right? N is nothing but number of data points, number of observations. P is nothing but number of predictors, right? So how this formula is helping us, right? Let us take that scenario of our, let's say I have 11 sample, right? 11 observations, right? So what will happen if I have only one predictor? So that means I have only, let's say the duration of residence is one predictor and I'm trying to predict the attitudes towards city. That time there are 12 samples, but let me take 10, right? Let's say I have only 10 observations, right? So what will be adjusted R square? 10 minus 1, n is 10 minus p is equal to, let's say 1, number predictor is 1, n 10 minus 1 minus 1, 10 minus 2 is 8, so 9 by 8, right? So whenever I have one predictor, adjusted R square is becoming whatever you R square multiplied by 10 minus 1, if I have 10 observation, 10 minus 1, 10 minus 2, 8, right? 9 by 8. Imagine that I added 4 more predictors. To create equation rather than one predictor, I added 4 more predictors. So in that case, what will happen? N is 10, 10 minus 1, 10 minus number of predictors are, let's say 4, right? 4 minus 1, 10 minus 5 is 5, right? 9 minus 5, that is 1.8. Earlier, what used to happen in this equation, if let's only there was only one predictor, 10 minus 1 divided by 10 minus 2, 9 by 8. 9 by 8 is around 1.11, right? So when I'm increasing number of predictors, this value is also increasing. Correct or not? If rather than one predictor, I'm making 4 predictors in my equation, I'm putting 4 predictors, this value will become 10 minus 1 divided by 5, that is 1.8. So from 1.1 to it is becoming 1.8. So this value also will increase because this value remains constant. If I multiply this value also will increase. 1 minus that value will decrease because I'm subtracting from 1, right? If this multiplication value, total value increases, 1 minus that value will decrease. So anytime you add a predictor, P is predictor, right? So this ratio n minus 1 multiplied by n minus p minus 1 increases. So ultimately this multiplication value increases, that reduces your adjusted R square. Why we are doing this? Because our adjusted R square applies a penalty for the number of predictors included in the model. So we have to be careful whenever we are adding a new predictor. We should be very confident that yes, that predictor makes sense. Unnecessarily, we should not add certain predictors or independent variables which will artificially improve your R square value, right? Because like I said, anytime you add any predictors, most of the times it will happen that your R square value is increasing. So in multiple linear regression, whenever you have multiple independent variables, we do not look into R square value. We look into something called adjusted R square. Adjusted R square is built or like formula is created in such a way that anytime you are adding a new predictor will improve this value or increase this value, which will decrease your overall adjusted R square value, right? So this is just to make a check that you are not unnecessarily including any additional variable, right? So is this formula clear? Why it is like this formula is decreasing your R square value?
Yes, sir.
Sir,
So yeah.
sir, explain variability in Y means what, sir?
So explain like what we were trying to explain, right? My let's say that previous equation, if I take attitudes towards city, that is my y is equal to 1 plus 0.6 multiplied by duration of residence, right? By using that equation 1 plus 0.6 into duration of residence, how much variation in attitude towards city I am able to explain. So explain variability in y means by taking that variable y, only one variable x, that is my duration of residence. How much variation, how much change in y, that is my attitude towards city, I am able to explain. That is explain variability in y. Then total variability in y. Total variability is like generally what happens if let's say I do not have any model, right? Let's say I do not have any regression model, right? I want to predict something about your class. Let's say right now there are 38 students. I want to predict that what is your CGPA of a particular student, right? CGPA, what will be the marks he'll score or she'll score overall in the BRM, right? If I do not have any kind of model, baseline model is known as your average, right? And most of the time that's why we take, right? We take an average of the class. If somebody asks me that, okay, how much this person will score, if I do not have any additional variable, I'll just tell that, okay, he or she will score 7.1 or 6.8, which is the average CGPA of the class, let's say, right? So that is your baseline model. If let's say somebody scored 9, somebody scored 8, somebody scored 6, so that is the total distance from your average, that is the total variability in y, right? If I do have a baseline model, total variability in y means the distance from the mean, the distance from the average, right? So that is your total variability in y. How much by creating a model, by creating a regression model, let's say I take your previous marks in your semester 1, let's say that is a predictor of how much you will score in BRM, right? If I take that as my one of the predictor, by creating that model, that okay, your CGPA, current CGPA in semester 2 is some equation, let's say 5 or 6 plus 0.6 of your previous CGPA, right? If I'm creating that equation, how much that model is able to explain the variation on your CGPA or anything, right? Y is your dependent variable. How much variation in your Y can be explained by your model? So explain variability means explained by the model which you are going to create divided by the total variation. Total variation is if I do not have a model, what would have been my total variation? Total variation from what? Total variation from the mean, because mean is considered as your baseline model. Just imagine a scenario. If I just ask you, what is the average income of a person in Odisha, right? Randomly, I'll select one person. Tell me what will be the average income of that person. You do not have any information about that person, whether he is a salaried or a business or like how much of work experience he has. You do not have any other information. So what you will do, you will search on Google, what is the average income per capita in Odisha. Let's say it comes per month is 2000 rupees or 5000 rupees. Without availability of any information, that will be your prediction, right? So, but let's say that person is actually earning few lakhs per month. He is a good businessman. He is earning few lakhs or few crores in a month. So that will explain the total variability, right? But let's say you have created a model saying that okay, if a person is doing a business or number of work experience, location, education background, with that you have created a model which is able to predict that okay, he will be earning around 50,000 or 60,000, right? So now what happens? Actual value is, let's say how much? Actual like monthly income is 1 lakh or 1.5 lakh. What you are predicting? You are predicting is the 60,000 or 70,000 using your model. So how much variation you are able to explain? 60,000 of the total value 1 lakh, right? That is your total explainability of your model. How much like total of whatever like he is earning 1 lakh or 5 lakh. Out of that, how much able to you are able to predict through your model. That will be your R square value.
Yes.
So we basically create model to explain that whatever the dependent variable. Y is here dependent variable. Okay. Okay, so just go to the first equation quickly. CTRP is cumulative television rating points, right? So this is what your TV programs are, cumulative TRP, right? TRP, I think all of you know TRP. So if I cumulatively per weeks per month, what has been the TRP rating? That is your CTRP, right? Then money spent on promotion of the program, that is in rupees. Then revenue earned through in-program advertisement, right? So think about a TV show, right? If the TV show is popular, right? Lot of people are watching the TV show. A advertiser like HUL or PNG or ITC or any company will be trying to put their advertisement during that show. Let's say IPL is happening, right? For advertisement, they will be charging few crores of rupees, right? So that is your cost, right? So that is your money spent on promotion of the program, right? How much you are promoting. Revenue is by promoting how much actually, how much impact you have created, how many people have seen your advertisement, and accordingly how much revenue you are going to earn, right? So what is our model is trying to create, whether revenue earned through the in program advertisement, right, is dependent on money spent on promotion of the program and cumulative television rating point, right? So correlation is not required. Let us directly create a multiple linear regression. Let me just delete this. So if I want to create a model which will tell I can predict my revenue if I know what is the cumulative television rating point and promotion money spent on the promotion of the program, right? So what is my alternate hypothesis? What I want to prove? If my objective is to find out the whether your revenue of a like revenue earned is dependent on promotions, money spent on promotion and CTRP. What will be my alternate hypothesis?
Revenue earned to the program advertisements is dependent on the cumulative television rating and money spent on promotion.
P and CTRP, right? then null hypothesis will be doesn't, not dependent, right? Revenue on, that is R. Not dependent. So study aim is to find the dependency of revenue on promotion and CTRP. What are my variables here? Revenue,
TRP,
TRP and P.
and what are those like variables type? Metric or categorical?
Metric.
All three, if you see, all of them are in metric. So my independent are P and CTRP, right? So then you know how to create a regression equation. Go to data analysis. The input Y range, input X range, labels, range. Okay. So see here, your not R square is 0.8319, adjusted R square is 0.822. So whenever you are creating a multiple linear regression, always remember you have to take multiple R square, right? Not R square, right? So okay, we'll go back to, so what does this ANOVA table says? What does this ANOVA significance means?
So it is the overall P value, that is the model summary is saying that total it is saying that it is significant.
So any other answer? So Oliver is telling model is significant. Is there any other answer? So when you say model is significant, either we can look into F statistics, you can look into the critical value or significance F value, right? So this is, if you see, this is less than 0.05, right? So you can say that this model is significant. So what does it mean, model is significant? So if I take a population, right? So this is for 30 respondent. For the population also, I'll create a model where this model will work fine, right? So like, but within what? Again, remember, within the range of this, within the CTRP rating, what I've taken, and what is the promotion rating, right? Here, let's say promotion, what is the maximum value of promotion? Or, sorry. So maximum value of promotion amount in that program is 2,08,800 rupees, right? And minimum value is 75,600 rupees. Similarly, CTRP rating, if I look into 90 to 156, 156, right? Maximum CTRP rating is 156. What I am trying to say is that this overall model will remain true within the range of this, within the CTRP rating of 90 to 156 and promotion amount between 75,600 to 2,88,000. If somebody comes and says that my promotion I'm going to spend 4 lakhs, can you predict what will be my revenue, right? I can still predict, but that will be not significant. I'm not confident on that. So my confidence on my model, my significance of this model is within the range of my dependent variable. So I have two dependent variable, that is promotional money within the range of 75,000 to this 2,08,800 and CTRP rating from 90 to 156. Is this part clear?
So, one doubt, sir.
Yeah.
So in the regression, in the data analysis, which are the cells you selected? I missed that part, sir.
Regression, can you please repeat?
In the after going to data analysis, you selected the rows, right? So which are for the first section, which rows you selected, and for the second one, which rows you selected?
Yes. So what is my input Y range? Y is my dependent variable. My revenue is dependent variable. So I've selected only this column, right? D2 to D40, right? Including the text, the title of the column. Input X range, I've selected both. So I've selected from these two total.
Okay, sir.
Okay. B2 to C40.
Sir, if I don't select the name, the first column,
Yeah, so
the
this
answer will be
you do
different,
not,
right?
don't put labels. So I've clicked here labels
Okay.
because here when I click labels, that the algorithm or the Excel will know that the first row which I've selected is a text. It will not take it for calculation. Okay, so if I'm not selecting these labels, only select the numbers. Okay. Okay, so now about the model. Model is significant within the range of dependent variable. Then we know that these p values are significant, right? So what does it mean? So my explain will reject the null hypothesis. That means yes, both of my CTRP and P null hypothesis is rejected. Is rejected. Then your revenue is dependent on whatever my alternate hypothesis that remains. So revenue on is dependent on P performance and CTRP, right? Then I guess you know that how to like interpret this per unit change in your CTRP, right? Your this TRP, right? Cumulative television rating points. Your revenue is increasing by 5931, and per unit increase in promotion, your revenue is increasing by 3.13, right? So that is about your what else is there? T statistics. So how do you get this T statistics? So T statistics is nothing but if you remember what is our one sample T test, right? What you used to do? Observed value minus expected value divided by standard error, right? So observed value is here coefficient, right? Minus expected value is 0. Why expected value is 0? Because my null hypothesis says that there is no relationship, right? So expectation is 0 divided by my standard error. So if somebody asks that how do you getting this T statistics is nothing but my coefficient value divided by standard error. Right, for all of them you can calculate like this. CTRP, that is my coefficient divided by standard error, that is my T statistics 10.28. Okay. So what else? Then you will say that okay, like that depends. Like let's say this CTRP value, let's say this is greater than 0.05. Then and p value is significant. That might be the case. Then we'll say that your revenue earned is only dependent on your p, not on CTRP, right? Or it might be case that okay, both the values, p values, let's say more than 0.05, it is 0.8 or 0.9, right? Then we'll say that revenue is not like dependent on these two variables, right? Still you'll get R square value. Still you'll get R square value of 20%, 30%. So that means by using those two variables, right, you are able to create a model. But if I take a different sample, this model won't be significant or these variables won't be significant. So remember what is the meaning of significant? The meaning of significant is this: if I'm getting this value in my sample, that will also remain true for my population. If it is not getting a significant value means for this sample this equation still holds, but it will not remain true for my population. Right? If I take a different sample, this equation or these values or these variables will not remain same. Right? This value, this coefficient value is what I've got. So this p value is related to these values, right? 5931, whatever I have got, right? So what does it say here? If I'm getting a significant p value, what does it actually say? So right now I'm creating an equation. What will be that equation? My revenue, sorry, what is happening? Revenue is equal to intercept is 41008.84 plus 5931.85 multiplied by CTRP plus 3.13 multiplied by P, right? So when I say significant, what I am trying to mean is that this equation will remain valid for any other sample within this range. If I take from any other location or any other TV source, this equation will still remain same, right? Still remain valid or still remain significant. If I am not getting significant, this equation still remains valid for this sample, but I cannot say that will remain true for any other sample, right? So that is when, if let's say my null hypothesis is not rejected, so this equation only will work for this sample, will not work for any other sample. Is this clear?
So p value means the probability that our null hypothesis is at what probability the null hypothesis will be true, right?
P value, yes, P value is if I believe my null hypothesis to be true, what is the probability of that I will get this kind of value?
Yes. So if it is showing that it is significant, means that probability is actually a good amount of probability, or it is showing that it is not.
So what is this value? This is very small, right? So this is 4 to the power minus 12, 1 divided by 4 to the power minus 12, right? So this is 0.00011 zeros.
Yes, sir.
So probability is very zero. Probability is very low. What does it mean? So if my null hypothesis is true, getting this value is very rare, right? Very improbable. What is my null hypothesis? Null hypothesis that no relationship. That means null hypothesis is not true. Because if null hypothesis would have been true, I would have got a higher p value. That means yes, there is a relationship. But let's say this p value is coming 0.8 or 0.23, right? So what does it mean? Let's say that rather than this number, if I put, let's say 0.23 per CTRP and 12 per P, right? Let's say these are the P values. So what does it signify? If I believe my null hypothesis to be true, which is there is no relationship between revenue and promotion and CTRP, there is a 23% chance that I'll get this kind of value. Right, that the probability is very high. That means null hypothesis might be true. Right, actually there is no relationship. I'm creating a model. My R-square might be still 0.8 or 0.7. This might be true for this model, but when I'm looking into the population, I'll not get the similar kind of values, 5931 or 3.13. If these values I was getting, but when I'm getting this low value, what it means say that I'll get a similar kind of value, not exactly this value. I'll get a similar kind of value in if I take in population.
Yes, sir.
So quickly do it for the other one. Here I have one categorical variable. So that is little different where I'm telling male is 0 and female is 1, right? So gender, work experience and salary monthly, right? Study M, again all those things you can write. So my alternate hypothesis is salary is dependent on work experience and gender. Salary is not dependent on study M, dependency of salary on gender and work experience, variables salary, work experience, gender, dependent variables is salary, independent variables is work experience and gender. Okay, so you see here work experience is metric and gender is categorical, right? So now the steps will still remain same. I want to prove that whether salary is dependent on work experience and gender. I'll go insert, sorry, data analysis, regression. My input y is salary, that is my dependent variable. Labels is given, then output range is age 19. Okay. So make sure that you are getting this similar kind of result. If there is any difference, tell me. So this is my R square, this is my adjusted R square. Model is significant, so I know that this model is significant overall. Model is significant. So now on the interpretation part. Now if you see here what is your p value, both are significant. Work experience, I guess all of you know how to interpret it, right? So so obviously my null hypothesis is rejected. So I know that salary is dependent on work experience and gender, right? So this I know. So work experience, for each year of work experience, your increase in salary is 2,749. Monthly salary is 2,749, right? And these values are significant. What about the gender? How to interpret this? So gender is telling minus 17,200. What does it actually mean?
There is an inverse relation.
So how to interpret this? Inverse relationship means I have only two gender, right? Male and female. One is male is 0, female is 1, right? 1 is female and 0 is male, right? So how to interpret this? Because work experience interpretation is very easy, right? For each year of, because work experience has given in years, for each year of work experience, right? Okay, one thing I think we have not discussed, whenever you are interpreting your regression equation, right? Always remember that something you have to mention, like keeping other variables same, each unit year increase in work experience will increase salary monthly by INR 2709.2. So this part is very important. So let us try to understand what does it actually mean. Keeping the other variable same, keeping the other independent variable same, which is gender. So when I'm saying that salary will improve by 2749, that is keeping that gender same. For this, if I'm comparing between two similar gender, like male, two male members, two male employees, one person who have work experience, let's say 5 years, other person who has work experience of 6 years. The person who have work experience of 6 years will earn more than the person who has work experience of 5 years by 2,749 rupees. So keeping the other variable same. Similarly, when we are looking into other equation, revenue R is dependent on promotion on CTRP, right? So if I'm trying to interpret, let's say promotion, right? If the CTRP ratings are same, CTRP ratings at the same level, for each unit, each rupee spent on promotion, your revenue earned will be 3.13 rupees. So अगर CTRP rating 100, let's say per TV show CTRP rating is 100, if you are putting one more rupee, your revenue earned from that program will be 3.13 rupees. Other way of telling for the CTRP, if let's say there are two programs, right? One have a CTRP rating is there are two programs. One program, so both the programs you are spending 1 lakh as your advertisement promotions, right? Let's say there is IPL match 1 and IPL match 2, right? Between two different teams, right? In IPL match 1, your CTRP rating is 100. IPL match 2, your CTRP rating is 101. So keeping the promotions level same, that means let's say if I for both the programs, both the IPL matches, my promotion amount is 1 lakh, right? Keeping the other variable same, keeping the promotion amount same, my CTRP rating, if there is a 1 unit change in CTRP rating, one IPL match which CTRP rating is more than the other IPL match by 1 point, I'll earn 5,931 rupees revenue, extra revenue from that match. So whenever you are interpreting multiple linear regression, remember the changes for one variable is impacting the dependent variable while other variables are remaining same. Same thing if I interpreting here. If I keep the gender of two or employees same, both are male or both are female. For them, if I'm comparing number of years that somebody who has, let's say, 2 years or 5 years more experience, they will earn 5 multiplied by 2,449 rupees. Right? Is this part clear? I hope most of you know this. Any question or any doubt on this? Okay. So keeping the other variable same, whenever there is increase in your work experience, right? So which is my other variable? Gender, right? If I'm comparing between two male employees or two female employees, right? Now the other way around. If I want to compare between genders to one male employee and female employee, right? I have to keep the other variable fixed, work experience as fixed, right? So how to interpret a categorical variable? This is something very important in multiple linear regression or any linear regression. So categorical variable, right? One is taken as a base level, right? Whichever. So here already dummy coding has been done. Some case dummy coding has not been done. Let's say male and female is given, right? One label you have to keep it as 0, right? So here male is already coded as 0, female is 1, right? So whenever we are talking about gender, it is already in comparison with your base label. Which is your base label? Base label is your male employees, right? So what it means is keeping work experience constant or same. Female employees, female is 1, right? Sorry. Will earn 17,200 less than male employees. So obviously this is on average. Right. So remember, whenever there is a categorical variable, there will be, so this is not an absolute change. Here it is absolute change. For 1 unit increase in work expense, if gender is remaining same, 1 unit increase in work expense, it is your salary is increasing by 2749. But in categorical variable, it is always a comparison. Comparison with a base label. Which is your base label? Which is coded as 0. Male is coded as 0. So when I'm comparing this, keeping work experience constant, right? So how to frame this equation? My equation is let's say 16,111.09 plus minus 17,200 multiplied by 2 into gender plus 2749.2 multiplied by work experience, right? So let me compare between one person who is male who has 2 years of work experience, one person who is female who has 2 years of work experience. So this is what I want to understand. Keeping work experience same at 2-year level, what is the difference in salary between male and female employees, right? If I am comparing two employees who have 2 years of experience each, what is the difference in salary between those two employees? So what will be my equation for male employees? 16,111.09 minus 17.200.2 multiplied by what is the gender for male? It is 0.
0.
Right? Plus 2 multiplied by 2749.2. What will be for my female employees? 16,111.09 minus 17,200.2 plus 2 multiplied by what is your work expense? 2749.2. So if I take the difference, so this is the value I'll get. So if I'm comparing between two, like keeping your work expense same, so comparison of categorical variable which always with a base variable. Here male is 0, that is a base variable, right? So what I'm telling, keeping work experience constant, a female employee who is 1, coded as 1, will earn, because negative is there, so will earn less, 17,200 less than male employees, right? So categorical variable always it is a comparison with a base level, right? Is this part clear?
Sir, if we put the female as 0 and male as 1, then it will be the inverse case, right?
It will be
The
positive.
female
So this symbol will become positive.
positive.
Yeah. So what will happen? Male employees will earn, male will become 1, will earn 17,200 more than female employees. So do that. So that is a good question. Just change the coding and you'll see that your equation will change. This
So
symbol will
comparison
become
will be with the base, means what we are taking as 0.
comparing, yes. Whichever you are taking as 0. Here you have taken male as 0. So female employees compared with male employees. If let's say I take female as 0, then male will become 1. Then in this case, this equation will become plus 17,200. So in that case, what will happen? Our work expense, same level of work expense, male employees will earn 17,200 more than female employees.
Or then female employees.
Result will be same.
So, but if we want to show that female employee are earning more than male, then how can we code that? Will that be possible?
No, with this data, so whatever your data suggests, right? So this data is suggesting, because whatever interpretation you are making based on your data, right? So if I want to prove that whether female employees are earning more than male employees, my data is saying no. So if your like let's say assumption is that female employees are earning more than male employees, this data suggests other way around. So we'll go and say that okay, I've collected sample data. Data is suggesting that female employees are earning. So this is how those gender studies happen, right? Whenever the salary comparison, this is the same thing, regression they build. So they take, let's say TCS or Infosys IT companies, they take at the same work expense level, same education level, what a male employee is earning, what a female employee is earning, right? Then they compare it. US a similar study they did for the same CEO, same companies, right? I think the average CEO was earning 5 million USD dollars more than female CEOs for the same group of, not the same company, similar kind of company. Same experience, same education, everything remaining same. Because obviously if work experience changes, you can always say that yes, because that male employee has better work experience, better education level, that's why he is earning more. But keeping everything same, that is how this gender study is being done. Keeping every other parameter same, when you compare, you'll find that. So in this case, like it is suggesting. Is this clear?
Yes.
So that's all for today. So we have completed regression. Again, I'm not say completed. This is again part of this. So go through all the, like I'll share the Excel file. Go through this, all of this. If still any doubt, anywhere, whatever we have covered, we can discuss that in the next class. Okay. Chalo, take care.
Sir.
Yeah.
Sir, can you decrease this response from 10 to 5 for other college and you just sir वो same college का आप कर दो
Not same college. No. So that
Sir,
already have.
कॉल भी रिसीव नहीं करता, कॉल कट कर देता, कैसे बोलूंगा फिर से?
So just imagine what will happen to your internship project. So internship, I think most people get similar kind of project.
Then sir, slowly and gradually we will learn. So if you decrease,
So you have 10 days, right? You have 10 days, and that time you have to get 100 responses minimum.
So we can go for only one college or one defined college.
Yes. That I have clarified. Anything other than kids club management.
So we can't go for like seniors of KSOM who graduated in 2021. Like we can go for them, right?
Yes, those who have graduated last year, you can go. Who have already graduated. Yes.
Okay.
Not your batch. Not your batch or existing who is continuing.
Okay. So like those who graduated in 2021 from our college, we can ask them, right? Okay.
Yes, yes. Yes, definitely.
Excuse me, sir.
Yes.
Sir, do the respondents have to fill the form from their college IDs or their personal IDs?
College
That
IDs.
is case. Sir, but not every MBA college have this college IDs. They don't provide, like some of the college in Bhubaneswar, they don't provide any college IDs to the students.
Then you mentioned that college do not have a college ID, so they are using personal email ID. Their roll number they have to provide.
Okay, okay. Sir.
Okay, chalo, take care.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Recording stop.